cat is staring at me at the door. He wants in. He wants his happy human time. Not getting it. Alrighty. So geometric series. Now geometric plays a little bit differently. And a lot of you think exponentials, and yes, that is a correct way to think on it in some ways. So what we need to do is find a common ratio for these. Now, sequence is geometric if the ratio of the consecutive terms are the same. Ratio is just a fraction, a over b. Okay, that's all you can think of ratio. We're going to take a term and its preceding term and see if we get a common ratio, which would be r. So what we have here is, here's some a sub n, or a sub 1. Here's a sub 2. We're going to take a sub 2 over a sub 1. So it's going to be 15 over 5. Should equal to the same thing, 45 over 15, 135 over 45. And absolutely they do. They come out to be 3. They all come out to be 3. So r is equal to 3. It is geometric. If you don't have this ratios all the same, it's not geometric. Straightforward. Okay, moving on. I wonder what that reminder was for. I think I have a PLC meeting, geometry, coming up. Maybe. We'll see. Okay. So what we have here is write the first 5 terms of the geometric sequence. So I could write the explicit formula, but let's think about this. This is my r right here. So what we're really doing is just doing 2 times 3 is equal to 6. All right, that's a sub 1. So a sub 2, we're going to take the 6 and times it by my rate, and I'm going to get 18. And then a sub 3, guess what I'm going to do? I'm going to take that 18, all right. I'm pretty sure I did this right. I'm going to take that 18 and do it times 3. So 18 times 3 is equal to 54. So on. Oops, that's a sub 2. All right. I knew something was wrong. A sub 1, it was given. All right. So a sub 2, a sub 3, and a sub 4. All right. And a sub 5, I guess we just do nothing more than 54 times 350 plus 12, 162. All right. Same thing here. We're given a sub 1, so I won't make that same mistake. And then I'm going to multiply to get a sub 2. I'm going to do 16 times 1/2. All right. To get a sub 3, I'm going to take that answer and multiply it by 1/2. And you can see the progression, 16, 8, 4. So you know the next one's going to be 2. All right. And guess what? A sub 5 is going to be 1. And of course, cut that in half and you get 1. So that's how geometric progression kind of works. So what we want to do is we want to start writing the explicit formula right here. Okay. And this one you got to watch out for. You have 2 numbers here always. You have a sub 1 times the rate. So you're going to have 2, 3 to the n or something like that. If you just see 3 to the n, that means a sub 1 is equal to a 1. So watch out. So when we do this, we're just going to plug into our formula. We're going to look for n sub 10. So a sub n, again, I'm going to rewrite the formula. So we're looking for a sub 10, so that's what I'm going to write right there. A sub 1 is 4. R is 3, so I'm going to put a multiplication sign right there. And we're going to do n minus 1, which is 10 minus 1. So that's going to equal to 4 times 3 to the 9th power, which is a really big number. I used a calculator. You can too, because this would definitely be on a calculator portion of a test. There you go. There you have it. Okay. Not too bad. Moving on. So let's take a look at this one. A sub 1 is 162. R is negative 1/3. We're looking for the 6th term. So let's go ahead and write our explicit. So again, our explicit, it'll look something like this. It'll be a sub 6 is equal to, well, a sub 1 goes right here. We're going to multiply it to my negative 1/3, which we're going to put in parentheses because we've got to raise the entire thing to the power. And then n minus 1 is 6 minus 1. That's going to be the 5th power. So a sub 6 is equal to 162 times 1/3 to the 5th power, which is what, 243 or something like that. So you just have 162 times a negative 1 over 243, because that's 9 times 9 times 3, is equal to negative 2/3. And that's it. That's all you have to do. Don't overcomplicate. We can make it more complicated, though. Let's find the ninth term of here. So what we're missing is our r. We need our r. We have a sub 1. A sub 1 is equal to 7. So that's helpful. We just need our r. In arithmetic, we're always looking for our d and c. Here, we're just looking for an r. Well, our r is nothing more than 21 over 7, which is the same as 63 over 21, which is equal to 3. So here we go. A sub 9 is equal to 7 times r raised to the 9 minus 1 power. Calculator time, because I have no idea what 3 to the 8th power is, some really big number. And that gives me 45,927. It's important you show your work, because if you put a calculator error and this is off just a little bit, and I don't know what you did wrong, you don't get credit for that. Moving on. So finite geometric series. We had infinite in arithmetic, and we'll have finite and infinite in these as well. So here's the formula that we tend to use, but in college you may see something that looks like this. And it's the exact same thing, that's all it is. All right? So don't worry too much about that. And this I right here is not your imaginary component. It's just something that a lot of textbooks use. So watch out for that. So when we have this, what we're going to do is, okay, what is my a sub 1? We need that. We're going to have to solve for it. That's nothing more than 2 to the 1 minus 1, which is equal to 1. Well, that makes it super easy. And we have our r. Okay, that is our r. So we can now plug in things into our formula. We're going to plug into this one right here. So let me rewrite it down here. S of n is equal to a sub 1 times 1 minus r to the n over 1 minus r. So we have our a sub 1 of 1. Again, it makes it real easy. And we're going to have 1 minus, well, our r is 2. And n is 9. All right, so the 9 goes right there. And then 1 minus 9. Okay? So honestly, 2 to the 9th power is some big old number. I don't know. A little bit bigger than 2 to the 8th. So 1 is fortunately easy enough to work. So when I put this whole thing in the calculator, which I did, I got 511. I need to show work. Okay? Make sure you're doing that. Some of you have low grades on your homework because all I'm seeing is an answer. Some of you would put something like 510. It's supposed to be 511. You get the whole thing wrong. All right? Moving on. So the next one. We're almost done. So we have, let's figure out what our r is. And many of you already recognize it as 3. 15 over 5 is equal to 45 over 15. So r is equal to 3, all right? And we don't know what this is. Now, you're not going to like me for this example, but we are in PreCal. This is not your elementary algebra class. So what we're going to do here is we're going to have to figure out what our sum is. Well, we got a sub 1. That makes it easy. But we don't have our n. Okay, so we have n is equal to 1. We don't know this. We don't know what this term is. So we can't use our sum. We're going to have to find it. So we're going to solve for n. Solve for n. And one of the easiest ways to do that is through logarithms. That's why I said you're not going to like me, but this is the course you signed up for. So we're going to have 1215 is equal to 5 a sub 1 times my r times n minus 1. And we're solving for n. Well, I'm going to divide by 5. That gives me 243. I see something with a base 3 here. I can absolutely convert this. If you know your 3 to the whatever powers, I can absolutely convert this to 3 to the something power. I already know what the answer is, but I'm not going to tell you. If you don't know what the answer is, you're going to use logs. So I'm going to take the log on both sides. Log of 243 is equal to log of 3n minus 1. That will come to the front using our log properties. Log 243 is equal to parentheses n minus 1 times log of 3. I'm going to divide by log 3 on both sides. And I get n minus 1 is equal to log 243 over log of 3. You can put that in the calculator, and you're going to get 5. So n minus 1 is equal to 5. That gives n is equal to 6. So 6 goes right here. So your sum is n is equal to 1, 6. Your a sub 1 is 5. Your r is 3. And this is just n minus 1. There's your explicit formula. All right? We can also now find the sum of this. So when we do the sum, oh no, we're just writing the sum, so we don't have to do it. Okay? So that's all we're doing. We're just writing the sum notation of this. Okay? Next. Infinite series. Now here is where the case where r has to be less than 1, a fraction. So we're actually approaching a number. Okay, it's like a limit in a lot of ways. Okay, so and this is something that if you can find YouTube videos on, does it sum of certain numbers actually equal to a certain number? There's a lot of YouTube videos on some of the debates on this stuff. It's really kind of entertaining. Suggest you look that stuff up after you knocked out another pre-cal class or calculus. Alrighty, so what we have here is we have our sum, and we're going to add up all these into an infinite. So basically, you're just going to plug into this formula right here. A sub 1 is equal to 1 minus r. That's a pretty darn easy formula to work for. Now remember, this is r right here. That's r. So a sub 1 times r, well, if you don't see anything there, a sub 1 has to equal to a 1. All right? So we're going to plug in. A sub 1 goes in the top. And we have 1 minus r, which is 3/8. Well, 8/8, 8, not a 5, an 8. All right? So 8/8 minus 3/8 is 5/8. So 1 over 5 over 8. Flip and multiply, you get 8/5. Right? That is the sum of the infinite series. This is a big deal in calculus. All right? And for those who are taking calculus, my juniors for next year, I strongly urge you open up that textbook and work practically every single problem in the pre-cal book. Okay, you can download them for free on the internet. Just type in pre-calculus PDF and you get 20 books. All right, so here my a sub 1 is equal to 4. R is equal to 1/4. Let's plug it into our formula. A sub 1 goes on top. 1 minus my rate of 1/4. That gives me 3/4. Flip and multiply, and I get 16 over 3. All right, so because of time, and we started well after spring break on the pre-cal, and plus the accelerated block, we didn't even get to pre-cal until March. We are calling it quits here. We're not going to go over any more sequences and series materials. Again, juniors, all right, yikes, that's all I can say. Hit the books over the summer, big time, because our pre-cal teacher will not, our calculus teacher is, he's going to prepare you for that AP exam, and they start day 1, literally, take roll, attendance, you're working. So be prepared for that, okay? Okay, I'll get this posted.